just so I don't forget. Okay, hello and welcome to week number 2, Algebra 2. I'm going to tell you this, and I'm going to be straight up front with you guys. This week, next week, and the following week are probably going to be the hardest 3 weeks. I mean, this week isn't too bad, but some of you will struggle with this week, I guarantee you. Next week is a bit tougher, and then the week on graphing sine and cosine, woo, takes it to a whole nother level. So be prepared. Be prepared. All right. This week we're going to be drawing angles in standard position. We're going to determine the values of trigonometric functions for an angle in standard position. So you're going to be dealing with sine, cosine, tangent, those kind of things will be there. Okay. Standard vocabulary this week: standard position, initial side, terminal side, angle of rotation, coterminal angle, reference angle. Whew, lots of angles. Okay, so, and hopefully you guys watched the lesson tutorial. There's no way I'm going to be able to go through everything during class. So if you have not watched the lesson tutorial, please go back and watch it, because I'm not going to be able to go through everything. I am going to do something a little different this week. I'm going to give you an example of one of the types of problems for each part of the assessment this week. So be prepared. All right, so now, when you draw an angle, positive rotation is going counterclockwise, which really doesn't make sense, does it? But positive rotation, when you're drawing an angle, positive rotation goes counterclockwise. So this is 90 degrees right here. Most of us know what 90 degrees is. It makes a 90-degree corner. And then this is 180 degrees, and you've got 270 and then 360. So all the way around the circle is 360 degrees. Okay. So when you do positive rotation, so if I asked you to, let's say I asked you to graph 195 degrees. Okay. Well, this is what it should look like. This is called initial side, and then this is 180 degrees, so this would be about 195 now. So this is called my terminal side. So I've got my initial side. The initial side is always your x-axis at 0, and then your terminal side is where your angle ends, and then you should draw an arrow. So this basically draws an arrow. This is about 195 degrees. Boom. That's 195 degrees. Now, if I asked you to draw a negative 270 degrees, then we would be going this way around the circle. Negative goes opposite, well, it goes clockwise. Okay, so initial side, terminal side. The initial side is where you start, terminal side is where you end. Just a little terminology, doesn't make a whole lot of difference. Now, you could have, let's say I asked you to draw an angle of 390 degrees. Well, that goes all the way around the circle, right? That's more than 360. So it's going to go all the way around the circle and then some. The way we show that is by drawing that arrow in here. So if I go all the way around, that's 360. And then I go another 30 degrees. That gives me a positive 390 degrees. Okay. I could ask you to draw a 1,000 degree angle. Okay. So you'd have to go, you'd be going around once, twice, 3 times. Okay. So you can draw any size angle that I should ask you for. Okay. So in this problem here, it says draw an angle with the given measure in standard position. Standard position is the x-axis. Okay, so if I wanted to draw 320 degrees, what I would do, so this is my initial side here, I'd go all the way around. So this is 90, 180, 270. So someplace right around in here, this would be a 320 degree angle. Negative 110. Well, if I'm going to do negative 110, guess what? I have to go clockwise now. So this is my initial side still, but I'm going to go this way. So that's 90. So this is about 100, negative 110. So there, oops, negative 110. Ah, very good about quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You will need that for the first problem on the assessment this week. Because on the first problem on the assessment this week, it says if you draw this angle, what quadrant does it end up in? Okay, so if I asked you to draw 990, and I said, which quadrant does that end up in? Okay, 990. All right, so I'm looking at this. It's like, okay, this is my initial side, which is 0. I have to go counterclockwise. So this becomes 360. If I go around again, I'm at 720. So now I'm going to go 990 minus 720, because 2 times around the circle is 720, right? So then I'm just going to see how much more I have to go. So now I still have to go 170 degrees more. So now I'm at 720. This is 90. This is about 170 more here. So which quadrant does this end up in? The arrow from the center, that always points the direction that you're rotating the angle. So right now, since I have this arrow right here, I know that I'm going counterclockwise around the circle. If I went this way, if it was a negative, I'd have to go this way around. That's why we draw those arrows, to show you which way you're going. If I went the other direction, I would not end up in quadrant number 2. Okay, so if I had asked you to do negative 990, well, okay, I'm going to do this in red. So if I asked you to do negative 990, okay, so I'd go around 1 time here, 360. I go around again, 720. So now I have to go another 170. So then I would end up right about here. So that, and then I would draw my arrow here showing that I went this way around the circle. And now a negative 990 would be in quadrant 3. So the first problem on your assessment, that's what it asks you. It gives you an angle, and it says, where does this angle end up? Which quadrant? So that's all you have to do. So you have to tell me which quadrant it's going to end up in. Yeah, exactly. Keep going around the circles. All right. Now, the reference angle is probably the most important thing that we're going to learn tonight. We're not going to use the reference angle a lot tonight, but we are going to use it a lot next week. Okay, what is a reference angle? And a reference angle is an angle, it says, for an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of the angle and the x-axis. Okay, so if I said, what is the, let's go 170 degrees. If I said, what is the reference angle to 170 degrees? Okay, the first thing I do is I draw in 170 degrees. Okay, so I start here, I draw in 170 degrees. It's going to look like this. Okay, this is my initial side, this is my terminal side. Now, what it says is the reference angle is the angle formed that is an acute angle, so your angle is always going to be between 0 and 90. So I know students don't understand reference angles when they give me angles like 120 degrees. It's like, no, that can't be a reference angle. A reference angle is always between 0 and 90 degrees. So what is this? If I drew this angle in right here, this is the angle between the terminal side and the x-axis. So this angle right here is 10 degrees. That's my reference angle. So 170 degrees, the reference angle to 170 degrees is 10 degrees. If I asked you for 225 degrees, what is the reference angle to 225 degrees? What would that be? Okay, what is the reference angle to 225 degrees? And I'm asking you guys to do it. So what is the reference angle to 225? Okay, step 1. Draw out 225 degrees. So I start here. This is my initial side. It's 180 degrees. This is about 225 right here. Okay, so this is about 225 degrees. This whole angle right here, up to here. So now so the reference angle is the angle formed by the x-axis. So this is my reference angle. What does this angle measure here? Well, if this is 225 and this is 180 right here, right? Because a straight line is 180. How far did I go past 180? I went 45 degrees past. This is my reference angle. So 45 degrees is the reference angle. Allison, I would go, because it went to 180, so I'm going back to 180, so I would have just done 225 minus 180. That would have given me my reference angle. Okay, let's try one more, okay, because it's very important. What is if I gave you the angle measure, let's say 330 degrees, what is the reference angle? What is the reference angle to 330 degrees? What's your step one? Okay, step one, draw out your angle. Okay, that's always your first step, is draw it out. I'm going to draw out 300. 150 can't be right. 150 cannot be right because it's more than is that between 0 and 90 degrees? No. It can't be anything other than between 0 and 90. Okay, so I do 330 degrees. Okay, that goes way over here. Okay, you guys understand how I got to 330 degrees. The reference angle is always the angle between the x-axis and the terminal side. This is the terminal side. This is the x-axis. This is my reference angle. What is my reference angle? What's left? If I go 330 degrees, what is this angle measure here? It's 30 degrees. That is a reference angle. Now, why is that going to become so important? Because when we do the sine of 330 degrees, you won't know how to find the sine of 330 degrees. But hopefully next week, you'll be able to find the sine of 30 degrees, and they are exactly the same answer, except one's going to be positive, one's going to be negative, and we'll talk about that later. But a reference angle is exactly the same thing. So the sine of 330 is -1/2. What is the sine of 30? .5. And what I said is the positive and negative are going to be the only difference in there. And I'll show you how to find if it's positive or negative next week. We won't talk about that, but you have to know how to find a reference angle before you can do that, because these are equal. Okay, reference angle and the angle. All right, so now we have to talk about trigonometry, because we're going to be doing a lot of trig. I don't like this. I don't like the sine of theta is equal to y over r. What I like is the sine of theta is equal to opposite side over hypotenuse. Cosine of theta is equal to the adjacent side over hypotenuse. And the tangent of theta is equal to opposite over adjacent. Do you guys remember that from geometry? Okay. So if I gave you, so tonight I'm going to give you triangles like this. And I'm going to say this is theta. I'm going to say this is 5, this is 6, and this is 4. And I'm just making these numbers up. What is the sine of theta equal to? And all you have to do is tell me the two sides. So the sine of theta is equal to 5 over 6. It's exactly right. This is my angle, opposite side, hypotenuse. What is the cosine of theta? Four over 6. Right, because cosine is adjacent side over hypotenuse. What is the tangent of theta? Yeah, you could say 2/3. Yep. Cosine would be 5 over 4. Right. Or I'm sorry, tangent would be 5 over 4. Right. So this is just a real quick review of trigonometry that you should have learned in geometry. Now, if you don't know that stuff, please go to the lesson tutorial this week, because I'm looking at the time and we got to get to our practice problems. Convert an angle measure between degrees and radians. Okay, this is probably the most important graph I'm going to show you, and you're going to need to know this for the next couple weeks. When we do graphs, we're going to be using what's called the radian measure. So this would be pi over 2. This would be pi, 3 pi over 2, and 2 pi. Okay, now the degree measures. This would be, so this is called the radian graph. Now I'm going to change this into a degree graph. Okay, I'm going to put the degrees that are exactly the same. 0 would be 0. Pi over 2 is 90 degrees, isn't it? Pi is 180 degrees. 3 pi over 2 is 270 degrees. And 2 pi is 360 degrees. So this is called a radian measure. This is called a degree measure. I always like dealing with degrees because it makes more sense to me. I understand what 90 degrees is. I don't understand what pi over 2 is. So I always go back to degree measure. Some kids, they use radian measure. Our book uses both. Now tonight, you're going to have to be able to go from radians to degrees and degrees to radians. So if I gave you a, let's say pi over 2, and I asked you what is the degree measure and you didn't know, you can convert. All you do is you multiply by 180 over pi. That is how you convert from radians to degrees. You just multiply. So here's a radian measure. If I multiply by 180 over pi, the pi's cross out. 180 over 2 is 90. Is that exactly what I have here on my graph? Yeah, harder math. When you get to calculus, it'll all be radians. Trust me. So you can convert from radians to degrees. You can also convert from degrees to radians. And guess what? In order to do that, you multiply by pi over 180. So if I had 270 degrees and I wanted to know what the radian measure is, I would just do 270 times pi over 180. I simplify, and guess what? I get 3 pi over 2. So the second problem on your assessment this week is going to be converting. So hold on to your hats right now. I'm going to show you exactly what's on the assessment this week. First problem, right there. It says, if each angle has given measure in its standard position, determine the quadrant in which each terminal side is. So 371 degrees. I'm only going to do one of these, okay? So 371 degrees. We can go all the way around. This is 360, right? So 371 would be right about there. Which quadrant does it land in? 1. Guess what? It says to show your work. This is your work. I need to see that. I need to see that. Do you understand? You need to show me your work. Okay. How about negative 2 pi over 3? It's a little bit more tricky. I wasn't going to do it, but I will anyways. All right, so first thing I do is I'm going to change this to the degree measure. What is negative 2 pi over 3 as a degree measure? Multiply by 180 over pi. So that gives me, that's 60. Whoops, is that right? 60, negative 120. Is that right? Negative 120. Okay, so now it's negative. So I go this way around. So that's negative 90. Negative 120 should end up right about there. Which quadrant am I in? 3. This is my work. This is my answer. It's problem number 1. Okay? Pretty easy, isn't it? I mean, it's not that tough. Not too bad. All right, problem number 2. Problem number 2, it says write each measure in radians. Express your answer as pi. and then write each measure. So you just have to convert from degrees to radians or radians to degrees. So if I had 36, so I'm just going to multiply this by pi over 180. Here I'm going to multiply by 180 over pi. That's all you're going to do. That's it. That's problem number 2 on this week's assessment. Problem number 3. It says find the measure of the reference angle for each given. Remember, it must be acute. So that means it better be between 0 and 90, right? So negative 120. So this is problem number 3 on the assessment. Negative 20. That means I'm going to go this way around. So negative 20 is about right here, isn't it? What's my reference angle? Now my reference angle cannot be negative. It's 20. It's 20. The reference angle is 20 because remember, the reference angle is the angle that is from the terminal side to the x-axis. This is my reference angle right here. So that's 20 degrees. Boom, done. Now this one's a little bit tougher because the first thing I would have to do is I'd change it to degree measure and then work it out. Okay, so that's number 3. Number 4, it says the given point P is located on the unit circle. What is a unit circle? The unit circle is a circle with the center at 0, 0 and the radius of 1. So this is my unit circle. Center is at 0, 0, radius is 1. Now why is that important? Well, all you're going to do for problem number 4 is you're going to plot this point. Negative 1/2 square root of 3 over 2. This is my x value, or x-axis, so I go over 1/2, right? That's your x-axis. Then you go up, because that's your y value. You go up square root of 3 over 2. Then you draw your radius in. What is your radius? 1, because it's the unit circle. So my radius is 1. Here is my reference angle. So now it asks me to find the sine of theta, cosine of theta, tangent of theta. What is the sine of theta? Correct. Yep. Because y is x is over, y is up, right? So this point right here on the circle would be 1/2 comma square root of 3 over 2. That's what that point would be. Okay. So now what is the sine of theta? Well, opposite. This is my theta. Opposite over hypotenuse. Square root of 3 over 2. Over 1, which is just square root of 3 over 2, isn't it? Dividing by 1 doesn't do anything, so I just leave it as square root of 3 over 2. Cosine of theta. Well, cosine is adjacent over hypotenuse. So 1/2. Tangent of theta. Now, tangent of theta, you're going to have to do some work. Square root of 3 over 2 over 1/2. What type of fraction is this? Complex. We can't leave a complex fraction in our answer. Remember complex fractions? So square root of 3 over 2. All we do is we just bring this and multiply by the reciprocal. Yep. So I've got the square root of 3 over 2 over 2. Boom. So just a square root of 3. That's my answer. Boom. Done. Pretty amazing, right? All right. Now, we do have to get to the practice for this week, or else you guys are going to really not like me too much, are you? All right, so here is the Desmos presentation. I'm going to share my screen with you guys. Okay, so let's get to the Desmos. That's a teacher. Okay, I think this is correct. All right. So, problem number 1. it says convert the angle in degrees to radians, express your answer as a multiple of pi. Okay, so it's asking us to, go from, it's asking us to convert. Was the actual answer for question number 4? Was that the actual? I don't remember. No, it was not. No, I made that one up. I think there's a negative or something in one of them. Tell you the truth. It's very close, but it's not exact. Okay, so in this problem, it asked me to convert from degrees to radians. That's easy. 144 times pi over 180. Okay. Oh, now I have to reduce. Okay, so I just take 2's out. So 2 goes into 180 90 times. 2 goes in here 72 times. Well, 2 goes into 72 36 times. 2 goes into 90 45 times. I can take a 3 out of both of those, right? So 3 goes into here 15 times. 3 goes into here 12 times. Looks like 3 goes in there again. So that goes in there 4 times. That goes in there 5 times. So I end up with 4 pi over 5 by my simplistic simplifying. I always just simplify the easiest number out. Now, some of you might look at it and say, oh, I can take out a 12 or something like that. I just take out, this is the easiest number I can. So I end up with 4 pi over 5. Does that make sense? I don't want to go on. All I did is I just multiplied by pi over 180, simplified it out. That's it. Okay. All right. Problem number 2 on the practice. Problem number 2, it says convert the angle in radians to degrees. Now, I am not going to do this problem right now. I forgot to take attendance so far, guys. So what I'd like you guys to do is I'd like you guys to do that problem. I'm going to take attendance real quick, and then I will be back. Hopefully you guys will have the answer by then. Okay. Doesn't take me too long to take attendance here. I just copy and paste. Okay, attendance taken. Whew, that was pretty quick. I'm getting good at this. All right, everybody says the answer is D. Now, if I did this problem again, it's just basically simplifying. So I've got 55 pi over 18 times 180 over pi. I like this one because the pi's cross off. The 180 and the 18, that's just going to give me 10 there, right? So now I just have 55 times 10, which is 550. Oh, that one was way easier to simplify out. I like it. That was easier in the way you did it. And simplifying, I see the 18 and the 180, and it's like, oh, 18 times 10, that makes it easy. Oh, you multiply and then divide it. And you can do that. I mean, you should get the exact answer. It's going to probably take a little bit longer. Yeah, that's so. Yeah, you can do it that way. Absolutely, that doesn't make a difference. I like to simplify first because then I'm not dealing with such huge numbers. All right. I like this problem. It says draw the angle in standard position, 13 pi over 6. Now, the first thing I do when I look at this problem is I have no clue what 13 pi over 6 is. Do you guys? Do you guys understand what 13 pi over 6 is? I have no idea. So the first thing I'm going to do is I'm going to change this to a degree measure because I know degrees. I understand degrees. I know 90, 180, 270, 360, and kept going around the circle. I don't know radians, and I've been doing this for a long time, and I still don't know radians. So I always change anything that's a radian measure. I always change to a degree measure because that makes it, to me, then I can look at it and say, oh, okay, that makes sense. So I'm going to simplify. 6 goes into that 30 times. Okay, so 30 times 13. 30 times 13, that's 9, that's 0, that's 3. 390, is that correct? Is that a 390 degree angle? All right, somebody said yes. All right, so I know that if it's a 390-degree angle, it's going to go around my circle more than one time, okay? Because one time around is 360. So 390 would be another 30 degrees. So this would be my answer right there. That's what mine would look like. So the only one that looks halfway like mine is letter C. But it was so much easier to graph this thing when it's in degree measure. When it was in radian measure, I'm sorry, but I could look at that all day long and not be able to tell you which circle that was, okay? It just, well, to tell you the truth, I probably could, because if I reduce 13 pi over 2 down, I'm sorry, over 6, that would give me 2 pi, because 6 goes into 13 2 times, so that would be 2 1/6 pi. I know what 2 pi is. It's all the way around the circle. So I know I'd have to go all the way around the circle plus 1/6. So I probably could have gotten that without having to do that, but I think it's much easier to just change it to a degree measure. Okay, that's just the way I would do it, but you can do it any way you want. I'm just telling you how I look at these problems. Okay, problem number 4, it says find the reference angle for the given angle. Oh, the reference angle this time. Again, it's in degree, or sorry, again, it's in radian measure. So the first thing I do is I'm going to change that radian measure into a degree measure, okay? So I'm sorry, I shouldn't put I want to put a multiplication sign in there. Pi's cross off. That gives me 60. 2 times 60 is 120. Okay, so I've got a 120-degree angle. I want to find the reference angle. So now the next thing I'm going to do is I'm going to draw out 120 degrees. What is my reference angle? What is the reference angle? 60 degrees is correct. Very nice. That is 60 degrees. Oh, no. But 60 degrees isn't up there. Oh, darn it. So guess what? I have to change 60 degrees, because this is 60 degrees, to change it back to a radian measure. So again, I know how to do that. So I'm going to simplify. That gives me 3 here. So pi over 3. That is my reference angle. So these problems are really getting you good at rewriting from radian measure to degree measure and degree measure back to radian measure. Pretty awesome stuff. And this stuff, as I said, it's going to come in real handy next week. It's something I can do. I just don't want to do it. Please, Mr. Jenkins, don't make me do it. Ah, yes, you must. All right, problem number 5. Problem number 5, it says, find the value of the indicated trigonometric function of the angle theta in the figure. Give an exact answer with a rational denominator. What does a rational denominator mean? It means you can't have a radical in there, okay? All right, so it wants us to find the sine of theta. What's missing? What are we missing in this problem? The hypotenuse. Can anybody think of a way to find the hypotenuse? Ah, the hypotenuse is the square root of 85. How do you know that? Pythagorean theorem. That's exactly right. In this problem, I would have had to use the Pythagorean theorem. A squared plus b squared. A squared plus b squared equals c squared. The hypotenuse is always c. So I've got 7 squared plus 6 squared is equal to c squared. 7 squared is 49. 6 squared is 36. That must be 85. So 85 is equal to c squared. So c is equal to the square root of 85. All right. So this is the square root of 85. So the sine of theta is equal to opposite over hypotenuse. All right. However, it said You cannot have a radical in the denominator. So how do we get rid of the radical in the denominator? Oh, how do I do that? I have no clue. All right, so let's say I gave you a fraction, any fraction. So this is not doing the same problem. Let's say I gave you this fraction. I said, you have 3/5, but I want you to rewrite that as a similar, the fraction, I want it to be exactly the same, but I want a 10 on the bottom. So what would you do to that 3/5 to get a 10 on the bottom? Times by 2. What would you multiply? Top and bottom by 2. Okay, I agree with that. And why can we do that? Why can we multiply top and bottom by 2? And I have to keep multiplying, going back and forth. Why can we do that? Because 2 over 2 is 1, and when you multiply anything by 1, it is the same thing, right? So if I multiply 3/5 by 2 over 2, which is 1, I get 6/10, which is the exact same fraction. It just doesn't look the same, right? Well, the same concept applies here. I'm going to multiply top and bottom by the square root of 85. Why the square root of 85? Why am I multiplying top and bottom by the square root of 85? Because that's the problem number. Well, it cancels out the bottom. It doesn't cancel the bottom. The 3/5, I just made that up. I was just trying to show you guys how you make an equal fraction. So the 3/5 was just made up. Now, why did I multiply by the square root of 85? What is, if you multiply across the bottom now, what is the square root of 85 times the square root of 85? It's 85. Right. Do you have a radical in the denominator anymore? No. What do I have in top? Well, I have 7 square root of 85. It didn't tell me I couldn't have a radical in the top. It just said I couldn't have a radical in the denominator, so I got rid of it. So my answer is 7 square root of 85 over 85. Letter B. That wasn't so hard to get rid of that radical, was it? You just have to realize, that, if you multiply by the square root of 85 over square root of 85, what are you multiplying by? You're multiplying by 1. That's all you're multiplying by. You're multiplying by 1. Doesn't matter. It doesn't look like 1, does it? But it is 1. I mean, square root of 85 over square root of 85 is 1. 5 over 5 is 1. 10 over 10 is 1. Anything over itself is 1, and we can multiply by that. All right. I'm losing my voice. I haven't taught in such a long time now. All right, number 6. It says the given angle is in standard position. Determine the quadrant in which the angle lies. Man, these problems are almost exactly the same thing as what your assessment is this week, isn't it? All right, which quadrant is that going to be in? Quadrant 1? I agree with you. Because if I was going to draw this out, because here's my work on this problem, negative 349 means I start here and I go this way around. That's 180, that's 270, that's 349. It ends up in quadrant number 1. I agree with that. Awesome problem. Number 7, find the reference angle for 288. What if it's on the line? Then it doesn't end up in any quadrant. Then all you do is you say it's on the x-axis or the y-axis. That's all you would say, because then it's not in a quadrant. It's on the x-axis or y-axis. Good question. You must have done the assessment already, or looking at the assessment. But you are absolutely correct. If it ends up on the x-axis or y-axis, it's really not in a quadrant. We just say x-axis or y-axis. Yep. So the answer is 72C for the next question. Okay, so and here's my work. If this was a problem on the assessment, here's my work. Negative or positive 288. I know that this is 90, 180, 270, 288 is right about here. So this is 288 degrees. This is the reference angle. So all I did was I just took 360 minus 288. And is that 72? So the answer's letter C. Cool stuff. All right. Question number 8. It says, find the value of the indicated trigonometric function of the angle theta in the figure. Give an exact answer with a rational denominator. Rational denominator means you can't have a radical in there. All right. So I'm going to let you guys do this one. I'm going to stop talking for a bit. Let my voice calm down. Somebody, you can tell what the hypotenuse is just by looking at the answers. Probably, you could probably figure out that the hypotenuse is the square root of 130, right? Just by looking at it. Okay. So in this problem, we have this is theta, this is 7, this is 9. It asks us to find the cosine of theta. Well, the cosine of theta is adjacent over hypotenuse, so it's 9 over whatever the hypotenuse is. Obviously, it's the square root of 130, right? Now, if I had to find it, I would just do 7 squared plus 9 squared is equal to c squared. 7 squared is 49 plus 81 is equal to c squared. So that's 130 is equal to c squared. C is equal to the square root of 130. Okay. So cosine is 9 over the square root of 130. I cannot leave a radical in the denominator, so I multiply top and bottom by the square root of 130. So that gives me 9, the square root of 130 over 130. Boom. So letter A looks like a correct answer there. Yeah. So once you understand how to get rid of the radical in the denominator, it's not that hard, isn't it? And I would assume for those of you that are taking the ACT test in March, you will get some trigonometry stuff on there. Okay, that's why I'm going through trig right now. So when you get to there, hopefully you'll understand some of the concepts. All right, number 9. Find the exact value of cosine of theta. Okay, what is the exact value of the cosine of theta? You're right, and the Pythagorean theorem. Once you see that, and you definitely have to use the Pythagorean theorem. But this one, a lot of students would struggle with this one because the hypotenuse is given. So if I was going to do this problem, you know, I'm just gonna call this x here, right? So I'm just gonna go x squared plus 4 squared is equal to 8 squared. The hypotenuse is always your c squared. So now I have x squared plus 16 is equal to 64. So x squared is equal to, and then I'm going to subtract 16 from 64. And that's going to give me, what is that going to be? 48. Square root of 48. Now, how do you break up the square root of 48? Because I don't see a 48 down here, right? So how do you break a square root down? Well, you can break it down into 2 square roots of this multiplied. So I would say that this is the square root of, I'm just trying to figure out what goes into here. 16 times 3, that doesn't, does that work? So 48 is the same thing as 16 times 3, right? So I just rewrote it, the square root of 48 as a square root of 16 times square root of 3. Well, the square root of 16 is 4. Square root of 3 is square root of 3. So now I've broken it down. So this side here is 4 square root of 3. Find the exact value of cosine. Well, that's adjacent over hypotenuse. So I have 4 square root of 3 over 8. Simplify, square root of 3 over 2. Boom. Not 8 over, because remember, it's adjacent over hypotenuse. So it should be 4 square root of 3 over 8. Okay, and then you can simplify the 4 and the 8 down. Okay, because cosine is adjacent over hypotenuse. So the 8 should be on the bottom. Okay. All right. Number 10. If the tangent of theta is 7 over 24, where sine of theta is greater than 0, find the exact value of sine of theta. I'm going to let you guys work on this one. We do have a little bit of time. So, oh no, I just clicked and I have the spinning wheel of death here. I'm hoping you guys can still hear me. If you can still hear me, work on this problem. I'm going to wait till the spinning wheel stops so I can go back into my other tab so I can see what you guys are doing. Can you guys still hear me? If you... Not sure if you guys can hear me or not. Bummer. Okay. Whew. Oh. All right. It went away. The spinning wheel went away. All right. Beeps are reassuring. Thank you. Okay. So try this problem on your own. It's a little tricky. I like it though. All right. So give it a shot. See what you get. Two answers of A so far. All right. So here's what I would do on a problem like this. I'd make my triangle out. Okay. I'd put theta in. And then I know tangent of theta is 7 over 24. Well, tangent is opposite over adjacent. So I just 7 and 24. Then I'm going to find the missing side here. So 7 squared plus 24 squared, which is equal to c squared. I need my calculator. Where's my calculator? All right. So I've got my calculator out now. So I've got 7 squared plus 24 squared is equal to 625. The square root of that must be 15, right? Yeah. Nope, 25. Sorry about that. Okay, so this gives me 625 is equal to c squared. C is equal to 25. So that gives me 25 there. So now it wants to know what the exact value of sine is. Well, sine is adjacent. I'm sorry. Sine is opposite over hypotenuse. So the sine of theta is equal to 7 over 25. Letter A is the correct answer. Whew. That was some awesome work. Now, I showed you what was going to be on the assessment this week, correct? Did anybody start the assessment already? Samantha, did you start the assessment? No, I know somebody did because they emailed me last night about the unit circle. You're just good at asking questions. All right. But if you open up the assessment, you will see the exact, what I told you was on there is going to be on there, okay? I know we have a few new students in this class. There's, I don't try to trick you on the assessments. I try to give you the same type of problems that we're doing on the assessments, okay? So I'm hoping that it works. Now, remember, we do have a help session on Wednesday afternoon from 1 o'clock until 2 o'clock. If you guys ever need any questions, please feel free to come to the help session, okay? All right. You guys have a great week. Tomorrow it's supposed to be 43 degrees outside. Get outside and enjoy the warm weather. Bye. And then it's going to get cold again. It's only Wisconsin. Bye.